Okay, so here we've got the diagram shows 4 particles PQRS of mass 10, 5, 2 and 3 kilograms respectively, attached to light rods which are rigidly joined together. Okay, the positions of particles PQRS in the XY plane are those coordinates there. Now, what you need to focus on here is the fact that they're attached to light rods. Now, the word light in mechanics simply means, right, that there's no weight. Okay, right? So the rods have no weight. So when we consider the center of gravity, we can ignore the connecting rods. Okay, so we can ignore them. We don't have to worry about the rods that are connecting these particles. Okay, because they are light, they've got no weight, so they're not going to affect center of gravity. Okay, so remember that, no weight. So we can ignore them. All I'm going to do is focus on the points P, Q, R, S, and they've put it in a coordinate system for us. Okay, and they've even told us the coordinates, haven't they? And the masses of them, okay, they've told us there, haven't they? 10, 5, 2, and 3. So I've written them down there. All I need to do now is write down the center of gravity, okay, of each of them. So the center of gravity, for instance, of Q will be 3, 8, yeah, because you go across 3, up 8. So if you remember in part A, I split this up into two columns, didn't I? I said center of gravity from, like, I think it was AC, and then center of gravity from AB. Well, the same thing here, okay? So I could do center of gravity from the x-axis and y-axis. But instead of saying, look, from the y-axis, from that line there, the distance is 3, and then from the x-axis, the distance is 8, I could just write down the coordinate, okay? And I can deal with that then effectively. So let's start off with where P is, because P is there. So it's 4 from the y-axis and 0 from the x-axis. That's the coordinate there. Q is 3, 8. R is minus 5, 6. And they give it to us up there, don't they? Anyway, and then the other one then is minus 1, 2. Okay, S is. So then the overall lamina then, so I'm calling it lamina, but basically the combination of those weights is basically all of these combined together to give us the whole system. Okay, so I just got to add these, yeah, and I'm adding them because nothing's been taken away. Okay, it's not as if something's been cut out. So if I add them, I think that comes to 20. Okay, and then in terms of where the center of gravity is, well, it's going to be somewhere in the middle here, isn't it? Somewhere between them. Okay, perhaps closer to the P, isn't it? Because P is the heavier mass. It'd be around here somewhere maybe. But we're going to call it x bar, y bar, the coordinate. Okay, so I don't know what that is, but we'll work it out now. So what I do then is I take moments. Okay, so the first of all, I take moments about the y-axis. Okay, to work out what my x bar is going to be. So moments about y-axis. So I can say, look, moments about OY. You can call it that if you want. OY. So the resulting lamina is 20, and of course, wherever it is, suppose it's there somewhere. Well, from the y-axis then, I need that x distance, don't I? I need that x distance there, that x bar there. So 20 times x bar, and that would equal then, well, the x distance then from each of these masses. So 10 times 4 plus 5 times 3 plus 2 times minus 5 plus 3 times minus 1. So 20x bar will equal, so let's work that out on my calculator. So I get 42 there. So straight away then I get my x bar, 42 divided by 20, and that comes out to be 2.1. Okay, so that's my x bar. So that's the horizontal distance, we across 2.1. All right, that's where it should be. My y bar then is basically how far I am from the x-axis. Okay, so I'm going to take moments now about OX. Okay, so then I take the overall lamina 20 and I times it by the y distance from the x-axis. Remember, it's the weight times the distance from the axis we're taking it about. So we're taking it about the x-axis, so it'll be distance there, which is y bar. And then you do each mass then, so 10 we start with, times by 1 is 0 there. So it's got no effect. 5 then times 8 plus 2 times 6 plus 3 times 2. Okay, so 20 y bar will equal to 58. So then y bar will be 58 divided by 20, and you get 2.9. So my centre of gravity will be 2.1, comma 2.9.